Page 6. All right. So for something to know if we're moving left or right, that is straight up velocity is positive or negative, right? If they gave us velocity, how am I going to find out my velocity at 1? Just plug in 1. That's huge. He's saying just plug in 1. So I need to go find V of 1. Wait, what'd you get for your V of 1?
1.911.
Agreed. 1.912, but they would have accepted 1. When my V is positive 1.912, are we going to say my particle is going left or right? Right. Agreed. So I'm getting rid of A because I don't like that and C because I don't like that. We cool with that? We're right at a 50-50. How am I going to figure out my acceleration? V prime is going to find my acceleration. V prime at what? Agreed. V prime at 1. Can my calculator do that for me? Yeah, we're going to do math 8 it as Mr. So what's this saying? If my V prime of 1 is positive, means my acceleration is also positive. Mr. Nelson.
Yep.
Do you agree that this can be a little deceiving based on what we talked about the last 2 days? Like F is typically the function. F prime is typically the velocity. And F double prime is typically the acceleration. Does it mess with us a little bit when they just say V is my velocity? They could have even named it just F, right? Because they told us velocity, this is technically the first derivative. And us taking the derivative of that is technically the second derivative. You know what I mean? We just want to be really careful with that. You agree since my acceleration was positive, we're going to go with B?
Yep.
Cool. Let's try the next one. I'm hoping that this is a gimme. They said, hey, the velocity is given. What is the acceleration when t is 4? They gave you a calculator. Go try it. I got C. You got C. What's the crucial thing? Did I put a 4 into my equation? No. You got to do it in terms of x and then tell it where you want that derivative. Cool. On the next page, we're even going to skip the top one, and I want to go right here to 90. Whew. Look what they gave us on 90. It says velocity is given. They love to give you velocity. And they said for what value of t, because instead of x's they use t, is the speed increasing?
So it's acceleration.
Okay, hold up. Speed increasing. When you get pulled over, what does the police officer tell you? You're speeding. What did they clock? Your speed, which is the same as your velocity, it just has no sign. It's always positive, right? So if I'm going east on 3rd Avenue at 60 miles an hour versus west on 3rd Avenue at negative 60 miles an hour would be my velocity. He's just saying you're speeding. So speed is always just the absolute value of velocity. So if they gave us the velocity and they said for what values of t is the speed increasing, I'm looking when that velocity is getting bigger, right? So you guys, what do I want to look at on my graph? Do I want to look at velocity?
Yes.
Yeah, let's do it. Let's just go to our graph. They gave me velocity, so I'm just going to type that in. I'm not going to math 8 that at all. I'm going to say we got negative x cubed. We got plus 2x squared. We got plus 2 to the negative x. Let's go take a peek at that, and you might want to zoom 6 it. At first, let's look at this. You guys, when I have you, let's just draw. We're going to sketch it. And if I were you, I'm just going to let you know it goes a little like this. That's what my sketch is going to be. It goes a little bit something like that. Now, you guys, this is a graph of velocity. What is my object doing right now?
Decreasing.
What is?
Velocity.
The velocity or the speed, sure, is decreasing. Which direction is it moving?
Don't matter. But left.
To the right because all of these y values are positive. Yeah, Healed.
My calculator keeps getting like an error.
My velocity is positive here. So it's moving to the right, but it's slowing down. Then it's still positive, still moving to the right, but it's
Increasing.
speeding up. And then it's still moving to the right, but it's slowing down. Then what happens right here?
Turn and goes left.
I go to the left. I change directions and I go to the left. What do I do to the left?
Speed up.
I start speeding up. You're going to get a point for writing this today. Why did I change directions right here? What wording do I have to use? What happened to my velocity? What? Change the signs, period. We know that my particle changed directions because the velocity changed signs. Could I say my velocity went from positive to negative? Sure. Is that more to write than change signs? So I just want us to get used to that wordage, okay? Real fast. They asked, where is the particle speeding up? Talk to me about what my velocity is doing here. Slowing down. What's it doing here? Okay, so I like this region. Okay, bear with me. What's it doing here? Slowing down to 0. Then what's my velocity doing? Then it's speeding up. I agree. It's speeding up infinitely because my velocity keeps getting bigger just in the negative direction. It just means it's speeding up to the left. Sir.
So are these points x values? X ranges?
Correct. Good call. He's like, wait a minute. These look like points, but this goes to yesterday. These are x intervals from x of 0 to x of 0.177. From x of 1.258 to x of infinity. Which two answers do we like right off the bat? We like A and E, right? Because they have that infinity. My x is going to go to infinity here. Okay? So I like A and E. How am I going to figure out this part? Yeah.
Do where it intersects the x-axis
Ooh.
to see which is the second
Maximum
point's worth.
That would get me that. I want to see, how would I do that with my calculator?
Second trace max will tell you where it stops going up.
Agreed. This is my max. What about this one? This is a min. Which one do we want to find? I feel like any of them will give us the answer in one.
The answer is E.
You want to find the max? Go for it. So when I go to my graph and I do the max, which is option 4, and I get that maximum is 1.256. Do I even have to write down my y? 1.256. It doesn't even matter. I can just put a question mark. It doesn't matter because this is from x to x.
Well, then it's
I'm just going to do this real fast. My min,
It can't be A because if you look at it,
agreed. Perfect logic, Greer. He's saying it's not starting at 0. My min, this little guy, has a point of 0.176. Don't even care about the y. And then to Stevie's point, this is a 0. Where it crosses the x-axis is a 0. So I do second trace 0, and I could find out that value, which again, we're being excessive right now. I'm just letting you know any of these would work. Do you agree if we're looking for this highlighted region, we got to go from this x, 0.177 or 176, to this x, and from this x to infinity. Yeah, Care Bear.
Sorry, what do you put on the calculator to like trace?
So what we're doing on page 8 is we're just using words to explain what these numbers mean now. I don't need a lot of words. We want to just be concise, okay? So it says people enter an amusement park at this rate. If this is a rate, what is technically E of t then? If it's a rate, are we talking position, velocity, or acceleration? Velocity. A rate is just going to be velocity.
For acceleration, it wasn't a rate.
They're never going to give it to you. Right, a rate of a rate. Yep, good call. Rate squared. Where E is the people per hour and T is hours after midnight. Using a calculator, let's first just go find this. How are we going to do that, you guys?
Math 8.
Math 8. Oh my gosh, so much Math 8. Math 8, 15,600. T squared minus 24t plus 160.
100.
Keep going.
107.958.
107.958. Dicey's going to give me 3 decimals, right, Dicey? Okay, we got to explain all this stuff. If E was already a rate and we found E prime,
People per hour per hour.
we know it's going to be it's an acceleration, right? When we say these words, we got to say the word rate twice. I know. At a rate. Okay, yeah. So we're going to start with people enter the amusement park. How did I say this? Ooh, what's that 11 referring to?
11 hours after midnight.
11 hours after midnight instead of saying 11 hours after midnight
11 a.m.
at 11 a.m. That refers to the time. At 11 a.m., the rate people enter the amusement park is doing what, you guys? If it was 107.958, what'd you say? Increasing, because it was positive. We have to use a word increasing or decreasing every time. Since it's positive, it's increasing. If it was negative, we'd say it's decreasing. We said rate once. Since we found,
Increasing at a rate.
yes, at a rate of, we got to say rate twice since we found the acceleration. Yes, 107.958. Use the units people per hour squared. I specified the time. I specified double rates, meaning the second derivative. I specified the quantity, increasing or decreasing, and the units. That's what they're looking for. Oh, okay, you guys, check this out. This is the last thing we're going to do today. Then it's the weekend, okay? Did you get that, Char? Okay, sorry, I thought I cut you off with your rating. You guys, I'm going to say Q is a quantity. Would quantity be position, velocity, or acceleration? A quantity. Just position, right? It's a length or an amount, okay? So if I'm saying Q is a quantity, and if Q is not changing, this is what that quantity or that position would look like. What would Q prime be?
0.
Equal to 0. So we're going to say, okay, Q prime is equal to 0. If my quantity is increasing, yeah, my Q prime would be greater than 0. And if my Q is decreasing, if my position is decreasing, yeah, my slope would be less than 0. Okay, so with that being said, last one that we're going to look at, the bakery. What bakery do we love around here?
Local one.
I know, I'm just curious. What do we like?
La Chatelaine.
Basic biscuits, La Chatelaine. What'd you say? Fox and Snow, so good. Dan the Baker. DK. I'll take a DK diner. What'd you say, Lai? Bell? Ooh, yum.
That one's good.
So you guys, they said the number of people in the bakery is this. Would you say B is a position, a velocity, or an acceleration if it's the number of people? It's a position, right? Where T is measured in hours and 7 a.m. corresponds to T equals 0 because it doesn't open till 7. Is the number of people in the bakery increasing or decreasing at 1? If I want to know if the number of people is increasing or decreasing, what do I need to look at? B prime, exactly, right? So I need to look at the rate of people coming into that store. And you said B prime of what?
6.
Agreed. Now, agreed, B prime of T would have been if I didn't have a calculator. I'm going to let my calculator do the work here, and let's go just calculate what is B prime of 6. Anyone get a B prime of 6?
Yeah, seriously.
X equals negative 28.172.
You might maybe just had a different decimal in there, bud. Did you do 24.6?